Hey everybody, today we'll do another video and today we will continue on the exact differential equations. Exact differential equations. So, in the last video we did an example, right? So today we'll work out two more problems. As far as the definition, I don't think it's necessary to explain it again. I guess we went through and we say that men, right? Men can, right? A male cannot get pregnant, right? That's what we said last time. Cannot have a kid, right? So that's why we can call it like male or female, but not birthing people. I mean, you can call it that if you want to, but is it right? I don't know. Is it birthing people? Is that the right? Okay. But anyway, I'm not gonna go through that too much because we do mathematics, right? But anyway, so we actually do it, the definition. The definition is very, it can be kind of complicated, but I'm not going to go through the whole thing because it's not really necessary. But basically, what it does is we take the partial derivative, partial m, actually it's a capital M, partial m over partial y equal to partial n over partial x, right? So that's the definition for those, right? So what it does is basically if we see at dx, we take the derivative with respect to y. If we see a dy, we take the derivative with respect to x. Right, so partial derivative, right? So, okay, so let's do then a problem that will, I don't know if my camera is working good, but I guess it's not working so good, but we will see. I guess it's kind of, okay. My camera's acting weird, but anyway. So we will do some problems. So we will do some problems. 1 second, please. So we will do some problems, and we will do one, and so this one says following. It says that check if it's exact. If it is, solve it, right? So we do 2x minus 1 dx plus 3y plus 7 dy. In that they have that set up to equal to 0. Okay, so we do it right here, right? So we take the derivative with respect to, if I see a dx, I take the derivative with respect to y. If I see a dy, I take the partial derivative. Remember, it's a partial derivative with respect to y. So So in this case, we take the derivative, we take the partial derivative of this, right? Partial derivative of m, which is this case, with respect to y, right? And we do this, which is, right? So actually, we can do it, actually let's do it like this. So 2x minus 1, right? Take the partial of this, right? Take the partial and we get the partial derivative of that. Remember, there's no y, right? We taking the partial with respect to y, but there's no y on it, right? So if there is no y, then the partial derivative with respect to m, of m with respect to y, is equal to 0, right? Because there's no y. Okay, so same thing here. So we do the partial m now with respect to x, right? I see a dy, I do a dx, partial derivative. I see a dy, I do a dx, right? Now, take the derivative of that, it's, right? So 3y plus 7, take the partial of that. Do I see an x? Do I see an x? I don't see an x, right? So I am assuming that x is 0. If I take the partial derivative of 0, then it's 0. So basically, the partial derivative of that with respect to x is 0. Right? So we have that those are equal. Now, we know now that this is exact, right? So what we do next is the following. So, okay. So we know this exact. Now we do the following. Now we integrate m, right? We integrate m, and m, so we have 2x minus 1, right? And we want to integrate that, right? So now, what do we have? Right. So we integrate that. Then, when we integrate that, this is equal to what? This is equal to, remember, that's a dx. If we integrate that, actually, just let me do it right there. So we integrate that and we get 2x squared minus x, right? And plus a g of y. Right. Now, remember I have to divide by 2 at the bottom, right? Take that exponent, bring it down, and that is the 2 right there. Right. So in this case, I have 2. I guess the camera can see it. Cancel those out. And I get x squared minus x plus g of y, right? So that is going to be important. That is going to be important. We'll keep it right there. Now, so with that being said, we have that, right? So now what we can do is take this and take the partial derivative with respect to y, right? Now we take that and we say x squared minus x plus g of y, right? Now we take the derivative of the function, right? So we said partial of f over partial of, and this symbol of the partial derivative look like 2, but it's not 2. I just want to make that clear. This is 2. This is not 2. So that's the symbol. So but also almost like look like. Now we taking the partial with respect to y, right? Taking the partial with respect to y of this, we get that this is equal to this is a constant, right? This whole thing is a constant. So if whole thing is a constant, then we get that g, we just take the derivative of this, a g prime of y, right? All right, so g prime of y, basically, that's all we get, because this is 0, right? So now we set up this into that, right? So now we say that g prime of y equal n, which is 3y plus 7. And then we take the integral of that, right? Now, when we take the integral of that, we say that the integral of g prime of y equal the integral of, we take it on both sides, right? So 3y plus 7. Then we integrate that. In this case, right here, we just get g of y. In this case, we get 3y squared over 2 plus 7y, right? Now, when we do that, okay, so now this is nothing but this I cannot reduce anymore. So this is nothing but g of y equal to 3y squared over 2 plus 7y. Now this is important also, right? Because the final answer is going to be this g of y is going to be replacing this g of y, with the final answer is going to be x squared minus x, right? Minus x plus what? Plus whatever this equal, which in this case is 3y squared over 2 plus 7y, right? And that is equal to a c, right? That is the solution for the first problem. Okay, so that's the first problem. Now, so let me just do another problem real quick. So this is the first problem. Right, so let's do another problem. And this problem says that it is 5x plus 4y. So 5x plus 4y dx, and then it's 4x minus 3y cubed plus 4x minus 8y cubed minus 8y cubed dy equals 0. All right. So, okay, so let's do this again, right? So first we check for exactness, right? We check for it if it's exact. If it's exact, then we try to solve it, right? That's what the problem statement says. So we take the partial derivative of this, partial m, right? Partial m over partial with respect to y. Why? Because I see a dx, I take the derivative with respect. I see a dx, I take the partial derivative with respect to y. So partial y of this, right? So in this case, this 5x plus 4y. See that? Now, take the partial derivative of this. This is a 0 because this is a constant number. So this goes to 0. And then I take the partial of that, which is nothing but the partial of that is going to be partial m over partial y, which is equal to 4. Right? So we done the partial derivative of the first of n, right, with respect to y. Now, we will do the partial of this with respect to what? With respect to x, right? So now we do the partial n over partial x, right? Because I see a dy, I do a partial with respect to x, and then in this case it's going to be 4x minus ay cubed. Right. Now, as you can see right here that this is a constant, right? So this is a constant. If this is a constant, that means this is 0. This is the, by taking the derivative of a constant, it's just 0, right? Now, so if I take the derivative of that, if I treat that as a constant, then I just will need to worry about this, which is the partial of n over the partial x, right? Then it's going to be nothing but what? Nothing but 4. Now, we see now that they are exact, right? They are exact because the partial derivatives are the same. Now let's do the rest. So now let's do the rest. Now we're going to integrate m. Integrate m, right? This is m. This is n. Now, integrate with respect to what? With respect to whatever I see it. I integrate that with respect to what? With respect to whatever I see in there. So I integrate 5x plus 4y dx, right? When I integrate this is equal to 5x squared over 2 plus 4y. I take this as a constant. Now 4 and y, they are constant because I'm integrating with respect to x, right? So now this is nothing but x, y. I just reverse the order, right? Because I am integrating with this with respect to x. So this dx becomes that x right there, and then the y is in front, right? Now, so now plus what? Plus g of y, right? This is important. I'm going to go ahead and keep it. Now we can go and see that now we can go and do the integration of this with respect, right? So we integrate it now, right? We integrate it. Now we take the partial with respect to y, right? Now we take the partial derivative. So, and then when we do that, we do partial, right? Over partial of this, right? With respect to y. Now, partial of this, right? So I do 5x squared over 2 plus 4y. Just keep it in order. X, y plus g out y, right? Now, take the partial of that with respect to y. This go to 0. 0. Now I gotta just take care of this, right? Now I just take care of this, right? Take the partial derivative of that. And this is nothing but, because this is a constant, so I just deal with this. And this is going to be 4x. 4x, but the y disappear, I take in derivative, and this becomes g prime of y, right? So that is important too. Now, what we will do is set this equal to n. Set this equal to n. What is n? This is n, right? So, so let's do that. So let's do g. Actually, let's do 4x plus g of y equal 4x minus 8y cubed, right? Now, remember now that this is n. This is n. This is n, right? Now, now, look at this. This is the beautiful part of this. When you're doing this type of math problem, you should feel it, that you're doing the right thing, right? You should feel it, that you're doing the right thing, right? So, now as you can see that I have a 4x on both sides, right? So what I do here is I subtract 4x, subtract 4x. Now this cancel out in this side and also that one, right? And I get a g prime of y equal minus 8x cubed. Now, look at this. I still have to do another integral because I have this derivative. I have to get rid of this g prime of this derivative. So, with that being said, I will do it here. So, okay, so let me bring this right there. So g prime of y equal minus 8x, it's an x, no, it's y. It's y cubed. Y cubed. So it's a y. Y cubed, right? Now, if I integrate that, right, I integrate that on both sides. right? I can put that in. I can put that. So I can put that in front, right? So it's minus 8y cubed. Oops, I don't need 2. I just need 1. Okay. So now when I integrate that, that becomes g y, right? I got rid of that. And then that's a negative, so that negative carries over and I get negative 8 y to the fourth, right, divided by that exponent that I got, right? Now this cancel out, right, with 2 on the top, right? 1 on the bottom, 2 on the top. Is it negative? Yes. So then I said, okay, so g y is equal to 2y to the fourth. Okay, so this is another important number, right? Because that is the number that's going to complete our answer. So the answer is going to be this, right? It's going to be that one plot in here. You can see it's going to be right there, right? So basically, so when I do that, I am going to actually is going to be it's going to be this one. So yeah, so this is going to be the same thing. So it's going to be that one. So it's going to be this plus that is going to be the answer. So the answer is going to be 5x squared over 2 plus 4xy plus or minus. It's going to be a minus because it's negative. It's a negative 2. It's going to be a negative 2. It's going to be a negative 2x 2y. I'm sorry. Negative 2y to the fourth. So that should be the answer, right? So now, I don't know if the camera can see right now, but I will write it right here. So the answer is 5x squared over 2 plus 4xy minus 2 minus 2y to the fourth minus 2y to the fourth, right, is equal to up to a z, right? Because this right here should be equal to, right, to a z. Right, so you can say that that's how we do exact differential equations, right? So thank you for watching, and I see you in the next video. Thank you for watching.